Okay, the so-called limit theorems. Kaya nga sabihin na natin, bakit kayo nakakapag-perform ng substitution sa mga ilang mga limit problems? It's because of the limit theorems. Kaya nga lang syempre, when you are doing the computation, di mo talaga ginagawa yung mga actual proving part because you are focused on the computation. However, being theorems, they do have proofs. Okay? So being theorems, they do have proofs. And then for this session, di na muna natin gagawin yung proof ngayon because it's not really enough yung time natin for this whole day to go over the whole proofs. But then I guess the materials that you are going to receive will show you the proofs. Or in fact, some textbooks, most textbooks in calculus already have these proofs. But then just to give you a complete set of material, ma-receive nyo rin yung mga proofs naman na ito. But then let me just end by saying that the limit theorems are there to take care of the computation part. Let's say, the first one is actually about uniqueness of a limit. So when you say uniqueness of a limit, if you are going to get the limit of a function as x approaches a, you cannot get two different limits. The limit is unique. Okay? So why is the limit unique? In fact, it is a theorem. And being a theorem, there is a proof of that. Okay? So because it's already nearing lunch, I will not go over the whole proof for this one. But then again, in the slide that you are going to receive for this one, ma-receive nyo naman ito. Okay? Yan. So actually, it's really a mathematical proof using the epsilon delta definition. So that is one reason. Sabi ko nga sa inyo, yung epsilon delta is also used for the rigorous proving. And this is one example. To show that the limit is unique, you need the epsilon delta definition. But then again, we will not be able to cover the whole proof for today because of our time constraint. But then you are going to receive the complete slide. And I think some materials that also have this proof. Okay? So again, hindi natin discuss ito. But then let me tell you, the limit of a function is unique. Okay, and there is the epsilon delta proof to provide that tells us why it is unique. That is one application of the epsilon delta. To prove limit theorems, you need really the epsilon delta definition. And this is one such example, the proof of the limit is being unique. So that's why hindi pwede magkaiba ang makukuha nating limit ng isang function. Okay, iisa lang talaga dapat. Okay? And then also, here are some other limit theorems. This first one is the limit of a constant. Okay. If you want to get the limit of a constant as x approaches a, it's the same as the constant. While the limit of x as x approaches a is just a itself. And again, this can be proven using the epsilon delta definition. But then again, unfortunately, due to our time constraint, we will not be able to cover that for today. So, kaya dito na magsisimula yung substitution techniques. Kapag constant, ang limit niya ay sarili lang. Pero kapag x, ang limit ng x as x approaches a is the same as a. Okay, so hindi talaga siya substitution. It's because of the limit theorems that we can do the substitution. Okay, here are some more of them. The limit of a constant times a function is just the constant times the limit of the function. And I'm pretty sure, familiar na rin yung ilan sa inyo dito. Kaya ito namang isa, kapag may dalawa kayong function and you want to get the limit of a sum or a difference, you basically get the limit of each one and get either the sum or the difference. So that's why pwede mo talagang sabihin that the limit is quite friendly. Kumbaga, if you want to get the limit of a constant times a function, it will just be the constant times the limit. Limit of a sum is just the limit of the first plus the limit of the second. And again, why is that so? Because we can in fact prove that. And the proof relies on the epsilon delta definition. Okay, if we have more time, we should gagawin talaga dapat natin dito. Kaya nga lang because of time constraints, again, I do apologize. And how friendly is the limit? Kahit yung product, if you have two functions and you want to take the product, the limit will be the product of each of those two limits. Even for quotients. Okay? Except when the denominator is 0, okay? Because it's either indeterminate or it is undefined. But then more of that in a while, okay? Paano kapag nag-0? Okay? Sige. And in fact, kahit sa mga may radicals, no problem. If there are radicals, you can also perform quote-unquote substitution. Look at this. Itong una muna, kapag naka-raise a power, the limit of a function raised to a power is just the limit raised to whatever is that power. And the same is the case for radicals. Ito at saka ito. Just be very careful. Kasi kapag yung ating radical kasi ang ating index is an odd number, there is no problem with the domain. However, you are already familiar that if a function is the radical of a function is even, let's say, square root of x, di ba? Pag square root, dapat yung nasa loob ay greater than or equal to 0. That's why mapansin nyo rito, for the case that n is even, medyo mas komplikado because we want to be very sure that the expression inside is greater than or equal to 0. Okay? Yan. Okay. So just to end today's session, let us do some simple computation. Okay, just to show you what will happen. Tingnan lang natin. Okay, and definitely we're going to end now. Sorry, 12 din na natin i-end. Okay, para tapos tayo sa part na to. Let's say you want to get this limit. May nag-message. Yeah, okay. Meron daw yung mga proof pala ay naroon sa, bibigay pala sa inyong module na MathTech 2023. Okay, thank you, Aaron. Let's just finish this morning with some simple computation. Let's say this one. What's the limit of square root of x plus 1 minus 5 over x squared minus 4 as x approaches 3? Sinabi na natin, hindi natin kailangan dito ng epsilon delta. We can use the limit theorems. Sabi natin kanina, kapag limit theorems at meron kang quotient, you can get the limit of the numerator and the limit of the denominator. So walang problem naman pala. Okay, may nagsabi na kaagad si Raymond. Okay? Pag nasa classroom na po, yung mga reminder, yung wala pa raw po sa Google Classroom, available na daw po sa Google Classroom ng ating MathTech 2023 yung module. So reminder sa mga hindi pa member ng module. Anyway, as I was saying, if it's a quotient, get the limit of the numerator, get the limit of the denominator. However, do notice, wala namang problem. You can really perform some substitution here. And again, that's taking care of the limit theorems. So at this point, since we already have limit theorems, you can really use those substitution techniques. Okay? Iningatan ko lang kayo ng simula that we are also immediately doing substitution. But then the limit theorems tells us that for very nice functions, we can do substitutions in getting the limit. And this is one such example. Let me just finish. If you plug in the values, you're going to get negative 3 over 5. So again, we can do substitutions because there are limit theorems to take care some of the nicer functions. However, paano kapag ito yung binigay sa inyo? What's the limit of square root of x plus 1 minus 2 over x minus 3 as x approaches 3? Okay? Siyempre, ang una pa rin nating attempt is to perform some substitution. So huwag kayong kakabahan. Pwede pa rin kayong mag-substitution para dito, di ba? Kaya nga lang, ano mangyayari pa nag-substitution kayo dito? Pag nag-plug in kayo ng 3 sa numerator, 3 plus 1 is 4, square root of 4 is 2, 2 minus 2 is 0, denominator 3 minus 2 is 0. So this is the case of a 0 over 0. Okay? And a 0 over 0, do a conjugation. Yeah, thank you, Raymond. So bago natin gawin yung conjugation, 0 over 0 is not undefined. The proper term is it is in fact an indeterminate form. Okay? Indeterminate in the sense that there are some factors that are common in the numerator and the denominator, and then we have to facilitate that. So for this one, as sabi dito ni Raymond, kailangan daw natin ng conjugation. What do we mean by that conjugation? We have to undergo some rationalization of the numerator. Okay, so I will not go over the complete process, but then again, for the rationalization, you just take the conjugate, in this case of the numerator, rather than minus, gawin yung plus. And after simplifying or taking the product, ito yung makukuha natin. Okay, at kapag tama yung inyong rationalization, you're going to see that there is in fact there is a common factor. At yun na nga, may x minus 3, and then after taking the product of the numerator, x minus 3 then. So after simplification, we're going to get that one. Okay? So wala palang problem. Ano, pag 0 over 0, the proper term is it is indeterminate and we can do something. In this case, just simply do some rationalization. And voila, we can already get the limit, which is in fact 1/4. Okay? So yun lang kailangan natin tandaan kapag 0 over 0 ang limit, it's not undefined, it is indeterminate. And now we have to settle. At ito ngayon nangyari, 1/4 na lang. And last one, ito pa yung isa. Mas madali itong isa. If you are going to again plug in negative 2, so yun naman talaga ang unang attempt lagi sa limit, the substitution. So di ko naman sinasabing mali yung substitution, pero ang kanyang nilang tandaan, huwag niyo tatanggalin yung idea that when you do limits, you're observing behavior. Hindi lang siya basta plug in of values. Okay? The substitution is there to make it easier. However, theoretically, rigorously, you really have to rely on the limit theorems. And the limit theorems are proven using the epsilon delta definition. Okay? Just to close today, this morning session, okay na to? Ano nakuha ninyo? 0 over 0 din ba? 4 minus 4 is 0. 4 plus minus 0 over 0 din. But then for this case, mas madali siya, no? Factoring lang yung kailangan natin. Thank you sa mga nagsasagot. Yeah, alam niyo na to. Okay? Sige. Okay. Yan. Again, ingat lamang, nag-cancel yung x plus 2 cos x is not equal to -2. And that is okay because we are just observing limits. We really don't need -2. We need the values approaching -2. And for the actual, yan, 4/3. So thank you sa mga nag-contribute. Okay? Yeah, that's it. So this afternoon, you are going to have encounter some indeterminate forms in the exercise. So I think you know now what to do. But then of course, hindi lahat kayang sagutin. Someone asked a while ago, paano po yung circular function na sin x over x? As x approaches 0, 0 over 0 din. But then unfortunately, factoring and rationalization will not work. Kailangan nyo na ngayon tinatawag na squeeze theorem for that one. Okay? But then let me just end today's this morning session. There are other indeterminate forms. Okay? Na-encounter nyo pa lang ay yung 0 over 0, but then infinity over infinity is another indeterminate form. Kasama din yung 0 times infinity, infinity minus infinity, 0 to the 0, ito pa, infinity to the 0, and 1 to the infinity. These are all indeterminate forms in terms of limits. So far, ang nasettle pa lang natin for today ay kapag 0 over 0, at kapag yun ay algebraic function. At the moment, you can do factoring or rationalization to remove the radical. Okay, but then in a general case, there are other techniques. And unfortunately, for some of these techniques, you have to rely on differentiation, and that will be covered later. Pero hindi po natin i-cover, wala po ngayon for this mathematic series, ngayong mathematic na to, wala pong, hindi mako-cover itong mga other indeterminate forms. Kung may familiar sa inyo, may tinatawag po yan. Thank you, Uli Mark. Nakalagay sa Mark, tinipe ni Luke, yung tinatawag na L'Hopital's rule. That really for some indeterminate forms, you can rely on derivatives to get the limit. Pero baligtad na siya. Kasi ang ginagawa natin ngayon, study the limits before derivatives, only to find out pala that later, you can also use derivatives to get limits to solve indeterminate forms. But then that is more, not for this session of MathTech. Okay? It's a fairly advanced. Okay? Kumbaga, you need a separate session for that one. Okay?